Okay, this is Algebra 1 notes, the last one for this chapter, so yay! It says notes 23 is graphing linear functions this time. So functions are different. And it says, okay, essential question is, what is function notation? Well, to answer that, we see function notation is where you have a f of x notation. And it is a function. So you cannot have x's repeat. Okay, so your function notation here, it has it written right here, and notice this looks like what you had yesterday of the slope-intercept equation, but this time it just has that f parentheses and x, and the way that is said, when you have this type of setup, what you say is f of x, which means this is a function of x. And it's a strange way of having it, but they're just making sure that this is a function. And remember, functions are where functions are where the x or the domain does not repeat. Makes it a function. And also realize this is the same formula we had yesterday. Y equals mx plus b. The same idea is holding true for today, just as long as we realize that the f of x is the same thing as y. Okay, the second vocabulary here, it says family of functions. We can have a whole group of functions that have a similar characteristic, and we classify them as family members or family functions. And then we also have parent linear functions. We have parent graphs that are the most basic of these linear functions. They're very, very basic. Basically, we're taking all the numbers away, and if you look over here at the column, you see that it has this f of x equals x on the end. That could be also y equals x. It's very, very basic. There's not even any numbers. Very basic. Okay, our first examples here, it says it wants to evaluate the function when the x's are these three numbers. So in my first table, I'm going to write down my three numbers. And this has the f of x again, so I'm going to write this as if it was a y equals, and then this 10x plus 3. Well, I'm still going to type this in my calculator. I'm sorry, I'll get my fingers out of the way. Excuse me. So I'm going to go to the y equals in my calculator, and I'm going to type in 10x plus 3, enter, and I want to go to the table, and I'm looking for negative 3. Let me focus. There we go. Negative 3 is negative 27. And then 0 right there is a 3. And then a 2 is a 23. Okay. So there is my table, and that's all they wanted me to do. That's it. We're done. Okay. On the next one, notice they have an S on this one, which if it's an F or an S or an H, it does not matter what letter they put in front, but this notation here represents a function. So they can have any little letter out front, but they'll always have an X inside when it's in your formula. So I'm going to do the same thing, as a Y. So I'm going to put negative 3, 0, and 2, and I'm going to type that into my calculator. So y equals negative 3.2x. We'll make sure you type it in right. We're going to go to our table, and negative 3, let me focus it. There we go. Negative 3 appears to be 9.6. Okay, 0 is actually 0, and then 2 is negative 6.4, and I have filled it out, and there we go. There's our answers. Okay, let me go with the last one. If I get that to focus, there we go. Here it has an H out front, but that's the same thing as a Y. And I'm still using my 3 values, so 3, 0, and 2. And now I need to put that in my calculator. So I'm going to go back to the y equals. and type in -1 divided by 4x. There we go. Okay. I'm going to go to my table, and -3 is a decimal of 0.75, and then 0 is still 0, and then the 2 is -0.5. So I've filled them out, and that's my answer for this exercise. Okay, the second type of examples, it says, okay, we want to find values so that this function has the given value. Now, if I'm looking at this, notice I have f of x equals, and it has 3x plus 1, and then it says f of x equals -10, or I'm sorry, equals 10. Well, remember, that is just the same thing as saying y has 3x plus 1 as well as y equaling 10. Same scenario. So I'm going to plug this one into y1 and this one into y2, and we're going to see where they line up in the table. Let me clear this out, and I'm going to put 3x plus 1 and then 10. I'm going to go to the table, and let's see. There we go. I have a 10 blue and a 10 red, so they're both there. My answer is 3. Okay. If I look at the middle one, let me change pens. This red's getting on me. Let's go with green. I guess we'll do Christmas colors. So I have y1 is going to be 6x minus 6, and then y2 is going to be 24. So I'm going to go back to my y equals and put in 6x minus 6. Oops, wrong one. 6x minus 6 and 24. And go to my table, and I'm looking for 24 right there. I have 24 on both columns. My answer is a 5. Hopefully this is getting easier for you to do this table stuff. Okay, let me change colors one more time. I have y1 is going to be the 7x plus 3, and then y2 is going to be the whole number of 17. So y equals, let's clear this out, 7x plus 3, and then y2 is going to be 17. I'll go to the table, and there is my 17, and the x is 2. Okay, so here is some important information down here at the bottom. Let me get my highlighter again. Oh, there it is. It says parent functions are linear functions. It means they're straight lines. Parent linear function is the most basic linear function. It has this f of x equals x is called the parent function, and then it says here f of x is another way to write just y on this problem. So you can have a parent function that looks like that mess, f of x equals x. Realize that could be g of x equals x, or h of x equals x. It can be any letter out front. Any of these also mean y equals x. All of these representations are the same thing as this. This is your parent graph. It's called the parent graph because it is the most basic graph. It doesn't have anything extra on it. Okay. The next example, this is actually example 3. I accidentally put a 2 there, repeated it. It says we want to graph the function, so we're going to graph this particular function given to us, and then we're going to compare the graph to the parent graph. So let me clear this out over here. Alright, so on this one, I'm going to use my skills that I had yesterday and say find the slope, which is an understood 1 there. So my slope is going to be a 1. I'm going to make that a fraction, so it's going to be 1 over 1. And then the b is going to be your y-intercept, and that is your constant that you have, so that will be 0 and a 4. I'm going to plot 0, 4. Whoops, I almost went down. 1, 2, 3, 4. 4 is up here on the top. And then my slope is up 1 and over 1. Well, that's off my graph, so I'm going to go opposite. I'm going to make both these negative. So down 1 and left 1. Down 1 and left 1. Oh, I need my ID. Oh. Here, this will work. Okay, so this, in the little bitty corner, is this graph g of x. Okay? We need to compare it to the parent graph. Now, the parent graph is the most basic graphs. Where's my parent graph? It says f of x equals x. Okay? If I was to graph this, let me stretch this out a little bit. Y equals x. It has nothing on the end, so that means there's a 0, and the number in front of the x is a 1. So the slope of the parent graph is 1 over 1, and the intercept is 0, 0. So it starts right here in the center. Let me change colors so that my parent graph always appears the same color. So 0, 0 is where it starts, and then it goes up 1 and right 1, up 1 and right 1, and it is that diagonal all the way across your screen. Okay, this yellow line is my parent graph. It's the most basic. It cuts it right smack dab in half. And they want us to compare it. Well, there's two ways to compare. You can compare it based on its y-intercept, and then you can compare it on its slope. So if I'm looking at this, the slope of my original equation was 1 over 1, and this slope is 1 over 1. So we can say that these two lines are parallel because they have the same exact slope. Okay? So we have same slope. And then it's not in the same position because the y-intercepts are different. From the parent graph, the blue graph actually slid up exactly 4 units. It's like taking that particular line and saying, okay, I'm going to push you up, straight up exactly the way you are, up here to the 4, and let you line up right there. So this thing we call is being translated up 4. Okay, so being same slope means it's parallel. Okay, and it's being translated 4 up. Okay, if I look at the next example, I'm going to go ahead and graph my parent graph because I know that's exactly the same. It's not changing. It's that diagonal cutting right through your graph, starting at 0, 0, and then doing 1, 1, 2, 2, 3, 3, 4, 4, all the way across. That's always going to be your parent graph. Okay? Alright, now this one, I have g of x, which that's the same thing as y, equals negative 3x, and then I need a plus something, and there's nothing there, so that means I have a plus 0. So my slope is given here. Now it's negative 3, but I need to make it a fraction, so put it over 1, and then the y-intercept is at 0. So when I graph my line, let me change this to blue, I start at 0, 0, so we have the same exact y-intercepts, but now it tells me to go down 3 and right 1, and here's my line. Okay, so now how the heck am I going to describe this one? Okay. On this problem, we have the 0, which matched on both. We had our parent graph had a 0, and this one had a 0. So my intercepts are the same. Okay, my intercepts are the same, but this time my slope changed. Okay, the slope, if I'm looking at it, this became negative 3 over 1, where the parent graph was 1 over 1. Okay, negative 3 over 1, the slope, if I'm looking at this graph, the mirror image of the parent graph, let me make it purple. What I mean by mirror image is if I flip the parent graph over here to this side, instead of 1, 1, it would be negative 1, 1, negative 2, 2, negative 2, 3, and it'd be going in this fashion. So since this line, this blue line, which is actually my graph, is above it, above the parent graph on either side, it's going to be above it, we're going to say that the slope is steeper. Because it's actually above my graph. Now if this was laying down more, it'd be less steep. It's getting flatter. So we really got to judge where our line actually is based on relativeness of our parent graph. Realize this is also a reflection. We do need to know that this is a reflection, or it's reflect. Okay, let me start again. F-L-E-C-T-I, is that reflection? Okay, we're going to leave it like that for now, and I'll figure out what it is, and I'll change it in class if I find out different. Reflection. It's reflexing over the y-axis. Okay. This is a little tricky to try to describe these, so I'll help you out in class a little bit. And I hope that was all on the screen. I just realized it was sliding up. Okay, so here's some independent practices. We'll go over these in class, so make sure you try to work them out. And don't forget to answer your summary on how to graph. Oh, what is a function notation?